So the unit 3 questions for the part that we have revised is telling me that a sample of liquid NH3 is brought to its boiling point. Which of the following occurs during the boiling process? The NH bonds within the NH3 molecule breaks apart. No, this is not the first thing that happens. You have molecules of NH3 that changes into a gas. So the bonds between the NH3 molecules is the one that breaks first, not the bonds between the N and H. This is wrong. The overall temperature of the solution rises as the NH3 molecules speed up. We know that while conversion, there is no change in the temperature. The temperature is only stable because the energy which is added is used to break up the bonds, not to increase the temperature. The amount of energy within the system remains constant. The hydrogen bond, so this also is not correct. The hydrogen bonds holding the separate NH molecules, NH3 molecules together break apart, and this is the only right one. So this is the amount of heat added is used to break up the bonds between each other. So here I have a group of molecules from alcohols, methanol, propane, ethene, and ethanol. Based on the strength of the intermolecular forces in each substance, estimate from greatest to smallest the vapor pressure of each substance in the liquid state at the same temperature. We know that the vapor pressure is inversely proportional to the intermolecular forces. So the higher the intermolecular forces you have, the lower the vapor pressure. We have the methanol here, which can make hydrogen bond. So here, this is the ethanol. I can see the ethanol here has also hydrogen bond because it has the O and H. This has no OH and has a propane. So let's have a look. The weaker the intermolecular forces here, it's easier for the molecules to, so when it is very weak, it's easier for the molecules to break apart from the liquid. So they begin to form a vapor, and then this vapor pressure increases. So let's start. The polar molecules have the strongest IMF. Which ones are polar but don't contain? Which ones are polar and don't contain hydrogen bond? All the polar here contain hydrogen bond, while this is non-polar. So this is non-polar, and this is non-polar. So I can see that the methanol and ethanol are both polar, but methanol has hydrogen bonding, means it has stronger intermolecular forces. Why does this one does not contain hydrogen bond and this one contain hydrogen bond? Because it has O and H. In the hydrogen bond, this is the trick that we asked about the last time. So if you have hydrogen bond, you should have three conditions. The first condition is that you have oxygen or nitrogen or fluorine. The second condition is that you should have a hydrogen atom inside the molecule. And the third condition is that the hydrogen should be connected to the oxygen or nitrogen or fluorine directly. Can you see the oxygen is not directly connected to the H? It's not considered as hydrogen bond. Only the oxygen is connected to the hydrogen here. So they are making a hydrogen bond. So this is the third condition of the hydrogen bond. It's very important. Most of the people miss this one. Okay, so I can say that this is hydrogen bond, so this is the strongest one. So I would say that the methanol is the one which has the strongest intermolecular forces. This means it has the weakest vapor pressure. So he is trying to estimate from greatest to the smallest. This has the weakest because this one has the strongest. After that, let's have a look. The ethanol still contains dipole, so it's still polar, so it contains dipole intermolecular forces of attraction, and this one does not contain it. So this one, I will say that this is ethanol. And then I have propane and ethene. The propane contains more atoms and more electrons than the ethene, so it will have a stronger one. So both of them is LDF, but this LDF in the propane has more electrons and atoms. That's why it is stronger. And then the weakest one is the ethene, which means that it has the highest, this is the weakest intermolecular forces, which means it has the highest vapor pressure. And this one is the strongest intermolecular forces of attraction, which means it has the lowest vapor pressure. When in a liquid state, which two substances are most likely to be miscible with water? Or in order to be miscible with water, you have to be polar. You have to be polar. So in order to be miscible with water, you have to be polar. And which ones are polar? The ones that's making hydrogen bond here, this is polar. And this is, as we said, is non-polar. So I will use only this one is non-polar. And this is non-polar. And this is polar also. But this one is hydrogen bond. And this one is dipole-dipole. So I will look for the polar ones, which is the methanol and the ethanol, and these two will be the correct answer. The others, the non-polar ones, cannot be included. Between propane and ethene, which will likely have the higher boiling point and why? Again, we said the propane and the ethene. We said that both of them are non-polar, but because propane has more atoms and electrons, so it will contain higher boiling point. That's why I would say propane, because it has more polarizable electron cloud, and the electron cloud is polarizable because it contains, so let's say it's more polarizable. And I would say that it's more polarizable because it contains more electrons inside it, of course, in the propane. Consider the Lewis structure for the following four molecules. All of the substances liquid at room temperature, organize them from high to low in terms of boiling points and clearly differentiating between the intermolecular forces in each substance. And this question is trying to arrange these structures from the highest to the lowest boiling point. So let's have a look at the intermolecular forces here. I have hydrogen bonding here because I have N attached to H directly and I have O attached to H directly. So these two have hydrogen bonding. They are the highest. But because this one has more electrons, it is more polarizable. So it have N butyl amine as the highest one. And then the methanol will be after it. The propanol has no hydrogen bond, but it is dipole-dipole because it has O and H. So this is the propanol, which is a little bit weaker. And then the pentane has the lowest boiling point because it's only LDF only. It does not contain any dipole-dipole or hydrogen bonding. So the pentane will be the lowest one in the boiling point. Consider the Lewis structure for the following four molecules. And on the methanol diagram reproduced below, draw the location of the all partial charges. The methanol is like that, C and H, H, and H, and O, and H. And I need to draw all the partial charges. So I will draw here a partial positive charge with this partial positive charge and a partial negative charge here. The N-butylamine is found to have the lowest vapor pressure at room temperature out of the four liquids, justifies the observation in terms of intermolecular forces. We know that when you increase the intermolecular forces, it will be the highest. Then you will have the lowest vapor pressure because the particles here are too much attached to each other to break apart from the surface of the liquid and form vapor. That's why it does not want to form the vapor. That's why the pressure of the vapor is low, so low vapor pressure. So the explanation is related to the vapor pressure, where the highest intermolecular forces will have the lowest vapor pressure. Again, we said why it's highly high intermolecular forces because of the content of the hydrogen bonding, plus that it is higher than the methanol in the polarizability because it has more electrons. So explain the differences in properties given in the table above for each of the following pairs. The bond strengths of N2 and O2. We know that the bond strength of N2 is more than O2 because it has triple bond. So N has triple bond while oxygen has double bond. This is stronger and shorter while this is longer bonds and weaker. The bond length of H2 and Cl2. The bond length of H2 is smaller than the bond length of Cl2 because the hydrogen is a smaller atom than the chlorine. So this atom is smaller. That's why the bond length here is in the hydrogen is shorter than that one of the chlorine. And the boiling points of O2 and Cl2, you know that both of them, O2 and Cl2, are both nonpolar molecules. So if we want to look at the boiling point, we know that both of them contains only both of them are nonpolar, and because both of them are nonpolar, so this means that they only depend on the electrons number or electrons count in their polarizability and on their strength of the LDF and intermolecular forces. That's why the Cl2 is weaker, higher than the O2, and because Cl2 is higher than the O2, then it's having more electrons and it is having more intermolecular forces of attraction or stronger intermolecular forces of attraction. Use the principles of nuclear bonding to explain why H2 and O2 are gases at room temperature, while H2O is liquid at room temperature. These two, we said that they only contain they are nonpolar molecules and contain only LDF. That's why they are very weak, while H2O contain also hydrogen bonding, which makes it more stronger intermolecular forces of attraction, allowing it to take the shape of the liquid by binding the molecules together with the IMF at room temperature. So that's why they are stronger intermolecular forces than O2 and Cl2.